Okay guys, so we're in section 4.1. This is problem 37. F of x is x squared minus 10. We're on the interval from -2 to 3. And I need to find the critical points and ultimately determine the absolute extremes. Okay, so I'm going to first find the critical points. That means I'm going to take the derivative, f prime of x. If f of x is x squared minus 10, the derivative is 2x. Okay, and then I'm going to set that derivative equal to 0 because critical points are where the derivative is 0 or the derivative is undefined. So that is going to be when x is 0. So that means x equals 0 is a critical point. Okay, if I want to find the y value that corresponds to that critical point, then I need to plug this x value into the original equation. So that corresponds to the point 0 squared, that's 0 minus 10, 0, negative 10, right? This is f of 0, okay, that negative 10 value. So I have a critical point at the point 0, negative 10. Okay, if I want to find the absolute extrema, the absolute min and absolute max, my options for that are any critical points plus the endpoints. Okay, so now I need to find the endpoints. That means if my interval is from -2 to 3, then I need to find f of -2 and I need to find f of 3. So if I plug -2 in here, then I end up with 4 minus 10, that's -6. And if I plug 3 in here, then I end up with 9 minus 10, that's -1. So I have the point -6 and +3, -1. Okay? So right now, my options are, for the extrema are 0, -10, -2, -6, or 3, -1. So I'm looking for the largest y value to be my absolute max, and the largest and the smallest y value to be my absolute min. So between -1, -6, and -10, -1 is actually my largest number, so this is going to be my absolute max at 3, -1. And then my smallest value is going to be -10, so this is going to be my absolute min. So this is a critical point, okay? If I were to think about this, I'll draw it up here, if I were to think about this on the graph, okay, again, I'm going from -2 to +3. So far I've located 3 points on this graph. I have the point -2, -6. So, actually, hold on. Let me adjust the graph slightly. Sorry about that. Make it a little bit, since all my values are negative, I don't need so much up here. So I'm going from -2 to +3. And here's -1, 2, 3, 4, 5, -6, 7, 8, 9, -10. Okay? Going from -2 to 3. So what I have is I've got the point -2, -6. I've got a point here. Okay, I've got the point 3, -1. That's up here. And then I have 0, -10 is here. Okay, now I haven't figured out anything else about the graph, but remember I know this was a critical point. If it's a critical point, then that means that the derivative was 0 at that point, and I know that it's a minimum, right? So this is going to be a place where the derivative is 0. So the graph of this is going to go from this endpoint down to a local min, which is also an absolute min, and then up to this endpoint, right? So here I have a local and absolute min, and then up here at 3, -1, that's my absolute max. Remember that endpoints cannot be local max or mins. They don't have neighbors, okay? But places where the derivative is 0, that has the potential to be a local max or min because it's in between the interval. Okay, so that's problem 37 from 4.1. All right, guys, this is section 4.1, number 38. The directions are similar to 37. I need to find the critical points, and then I need to find the absolute extrema, the absolute max and absolute min. My function here is f of x is x plus 1 to the 4/3, and I'm on the interval from -9 to 7. If I want to find for part A the critical points, then I need to find f prime. F prime, if I take the derivative of this is x plus 1 to the 4/3, so that's going to be 4/3 times x plus 1 to the 1/3, right? I dropped the power by 1. Chain rule, I multiply by the derivative of the inside. Well, the derivative of x plus 1 is still 1, so you don't have to write that there, but I am using the power rule, and within that, the chain rule. If this is going to be a critical point, I want to know where that derivative is 0. So I need to solve for x. Okay, so I'm going to write this in a slightly different way. This is going to be 4/3 times the cube root, because to the 1/3 power means the cube root of x plus 1, and times 1 doesn't change anything, so this is going to be equal to 0. If I want to solve for x, I'm going to multiply by the reciprocal on both sides. Well, if I multiply by the reciprocal, right, multiplying by 3/4 on both sides, the good thing is this side is 0. Here that crosses out. I end up with cube root of x plus 1 is still 0. I'm going to raise both sides to the 3rd power to get rid of the cube root. But 0 cubed is still 0, so I end up with x plus 1 is 0. And my critical point, at least the x value, is -1. Okay? Now, how do I get the corresponding y value? Just like in the last problem, I plug into the original. So if I plug into the original, -1, -1 plus 1 is 0, 0 to the 4/3 power, right? 0 to any power is going to be 0. Okay, but again, I get this value, this is f of -1. I'm not plugging into the derivative. When I want a point on the graph, I plug into my original function. Okay, so this is a critical point. Okay, it's a place where the derivative is 0. All right, now we're going to do part B, which is going to be finding the absolute max and min. Okay, so I'm going to erase this top part. I'm going to leave what I have there. Okay, I'm going to erase this so that we can find the absolute max and min. Okay, so this is part B. Remember, to find the absolute max and min, my options are any critical points and also the endpoints. So I need to find the endpoints. That means I need to find -9 something and 7 something, because my interval was from -9 to 7. So if I plug in -9, -9 plus 1 is going to give me -8. Now, let me do this out because this is fraction exponents here. That's going to be -8 to the 4/3 power. It might help you to think about this in terms of radical notation. This is the cube root of -8, and then raise that to the 4th power. So the cube root of -8 is -2, and then -2 to the 4th power is 16. So this endpoint is -9, 16. I'm going to do the same thing with 7. I'm going to plug 7 in for x. So that's going to be 7 plus 1 to the 4/3. 8 to the 4/3 is going to mean that I have the cube root of 8, and then to the 4th power. Cube root of +8 is 2. 2 to the 4th is 16. Okay, so I also have, these are my 3 options, right? I've got -9, +16, 7, +16, and -1, 0. Those are my options to consider for what is the absolute max and absolute min. If there's a tie, like in this case, then they're both considered the absolute max. Okay, so the absolute max here would be both 7/16 and -9/16. The absolute min is the lowest, so this is the absolute min. Since it's a critical point, it's also a local min. And I'm going to show you the graph right now just so we can picture this. Okay, move over to the other side. So, okay, I'll do the graph on this side. So we've got an interval from -9 to 7. Here's -9. Okay, here's 7. And I've got my points -9, 16. I'm going to erase that up there. Okay, so -9, 16 would be up here, 7, 16, somewhere up here. Right, if I call this my 16, and then I've got the point -1, 0. Okay. So here are my 2 endpoints. They're going to be my absolute max. And then here's my critical point, which is going to be my absolute min and also my local min. And so I don't know a lot yet about this shape, right? But I do know that somehow it goes from these highs up here down to those lows. Okay, so even just visualizing, even if I don't connect it, because it's not a parabola, I know it's tempting to want to connect it as a parabola, but even if I don't connect it, I can see, oh yeah, those are my two highest points, and then my lowest point. Don't worry so much about doing part C by hand, but you can use desmos.com, remember, as a graphing calculator, and you can put in your original function, and you can be able to see this graph. Okay, and I'll connect you, I'll link in a picture of that as well. All right, that's number 38 for section 4.1.